Okay, so we have dealt with finding the forces on force diagrams with flat surfaces, so no angles. So now it's time to introduce what happens, say, when you're moving something up a ramp. All right, in this case, we have an object that is at rest. So our velocity is 0, all right? And technically, the information we have here is sufficient to figure out the value for all three forces, all right? So to complete our force diagram, we have to find the values for all three forces. In order to do that, we have to make sure everything is vertical and horizontal so we can actually find net forces, okay? Because since our object is at rest, the net force should equal what? Hopefully you're remembering Newton's first law. Net forces always end up having to add up to 0. All right? So let's just get as much as we can done on here, and then I will show you how to break up the angled forces into their components so we can actually complete this. But since we know the mass, we can add the force of gravity on here. So force of gravity is equal to mass times gravity, which will be 15 kilograms times 9.8 meters per second squared, which is probably going to get cut off. But F sub g is equal to 147 newtons. Okay, so from here, we are going to do what is called the analysis of a force diagram. All right, the picture as shown without any components, if you were asked to, this is more for people who might end up going on to take an AP test or IB test. If you're asked to draw a force diagram, you're not supposed to draw the components on it. You're supposed to draw all the forces in the direction they're actually going. All right. So in the next couple of slides, what we're going to do is we're going to do analysis of a force diagram, which is where we are allowed to actually draw in the components and figure out what's going on. All right. So let's go to the next slide. I'm going to write in our 147 newtons here, but right now we have what looks like force of gravity pointing vertically down and then two angled other forces. Now, to make this easier on ourselves, you don't have to do components for the normal force and the frictional force. Especially since the only force we know right now is gravity, it'll be easier to break that up into components. So what we do in physics is we rotate. And your diagram ends up looking like this. Normal force is vertical, frictional force is horizontal, and it's the gravitational force that we have to break into components. All right, so let me make this a little smaller just so we have room. So our components are going to be F sub gy and F sub gx. Okay? So once you just get familiar with the fact that all you have to do is just slightly rotate, and then you can break the force of gravity into components instead of having to break every single force into components. All right, so I'm going to actually rotate this back just because it'll be easier to see the angle, or how I can prove to you that the angle works. So we have our 30-degree angled ramp. All right, so if we think of this line actually going down and making a right triangle, that means this angle right here is 60 degrees. All right, but this right here actually makes a second right triangle, which means this angle right here inside the triangle. So let's see if I can get a good arrow there. That, based on complementary rules, so if we go from the bigger right triangle having a 30-degree angle and then a 60-degree angle, but that 60-degree angle is combined with this right angle, that means inside the triangle, that angle is also 30 degrees, the same size as the ramp angle. Okay, so I'm going to teach you two different ways to be able to do this. Go with the one that you are more comfortable with. And I'm not going to do that. The only problem is that using the ramp angle, it's actually the opposite of projectile motion. All right, so forces, how you find the components is the exact opposite of projectile motion. Okay? Because in projectile motion, to find the x component, it was cosine, but when using the ramp angle, in this case, to find the x component, you're actually using sine, because it's the opposite over the hypotenuse. All right, so I'll walk you through it this way, and then I'll show you how you can actually make it match projectile motion, but then you're having to use the complement. So to find f sub gx, we have f sub gx over 147 newtons equals the sine of 30 degrees, or f sub gx equals 147 times sine of 30 degrees. All right, and that ends up giving you 73.5 newtons. Okay. And then to find f sub gy over 147 newtons, that's equal to the cosine of 30 degrees, or f sub gy equals 147 times cosine of 30 degrees, which gives you 127.31 newtons. Okay, so now we have our components figured out. So if I quickly redraw this, we have f sub f, f sub n, and then our fgy and our fgx, right? If we know that this is at rest, and we know this value is 127.31 newtons, and this value is 73.5 newtons, I'm pretty sure from here you can work out what force of friction has to be and what normal force has to be so that our net force is equal to 0. All right, so normal force will also have to be 127.31 newtons, and force of friction will also have to be 73.5 newtons. Okay? So, again, just a little reminder about the whole testing thing. This, when we draw our components on there, that's called the analysis of a force diagram. Okay? But this is how you do it using the angle of a ramp. I'm going to show you one more way how to do it using the complement of the ramp angle. All right? So once again, we talked about our f sub g y and our f sub g x. Okay, and we know that if this is 30 degrees, if the ramp angle is 30 degrees, this is 60 degrees. Inside here is 30 degrees again, which also then means if this is a right triangle, there, this angle right here is also 60 degrees. All right, so if you want to just remember that x is always cosine and y is always sine, in forces, you have to use the complement then of the ramp angle, okay? Because in this case, fgx is adjacent to the angle, and then of course FG being 147 is the hypotenuse, which means you can write it out this way. So FGX over 147 newtons equals cosine of 60 degrees, which FGX equals 147 times cosine 60 degrees, which gives you the same 73.5 newtons. And then FGY then becomes the sine of 60 degrees. And rearranging, we have FGY equals 147 times sine of 60 degrees, and that is equal to the same 127.31 newtons. So either way, you get the same answer. So you need to make a decision for yourself what's going to be easier for you to remember. Are you going to have an easier time using the angle that's given and then remembering that you have to reverse the cosine and sine? Or will you have an easier time remembering that x is always cosine and y is always sine, and for forces, instead of using the given angle, I have to find the complement? All right, so that's a personal decision on what will be easier for you to remember. But please fill out the online form, and I will see you in class.